Hagit Grushka Cohen, and I'm a PhD student at Ben-Gurion University. I'm going to tell you today about how to simulate data to assess the effect of sampling on anomaly detection in the domain of database activity monitoring. This research was done in collaboration with IBM Cybersecurity Center of Excellence, and especially for their leading product in database activity monitoring. So, I want to start my talk by giving you 244 million reasons why you should monitor your data. Let's say you're Google self-automated car company called Waymo, and your leading engineer, Mr. Lewandowski, decides to leave the company, not before downloading the entire engineering database that includes 400,000 files and 10 gigas of data, all of their data, all of their blueprints, everything, and taking it into your biggest component, Uber. Imagine you must be really, really angry that he did so. But if you did monitor your data, then you could prove that the data was stolen, leading to the trial dealing with whether the data was used or not. This trial was settled after only 6 days for $244 million. Well, that I would say that if I were Google, I would definitely think that the ROI, the return on investment for database activity monitoring was a hell of a thing. So I'm sure now everyone is going back and start, if you don't do that so far, you would start monitoring your database. Okay, so after convincing you that it is important, I want to tell you what database activity monitoring is. So just like in the criminal justice law, where the people are represented by two separate yet equally important parts, the police and the state attorney, we have here the collector and the anomaly detection. The collector is an agent that all the data go through, all the queries go through. We're talking about hundreds of thousands of queries per second. Hundreds of thousands of queries per second. So we cannot collect everything. We can't. We don't have enough resources for that. So as a result, we're only monitoring a small amount of the data. The anomaly detection, on the other side, gets these logs, these log files, the things that we saved, and decide which one of these things are anomaly. What is suspicious? What should be further investigated by the security officer? So the workflow is as follows. We have the data. Some of it is locked into files. These files are fed into the anomaly detection. The anomaly detection can only learn about the things that she sees and only from the data that she gets. The anomaly detection at time fires alerts to the security officers, which has to investigate them at the time. Today I'm going to talk about how we're sampling, how do we set the strategy for what goes into the anomaly detection. We also have research about how do we prioritize the alerts that are fired by the anomaly detection. If you're interested in that, then I invite you to find me at one of the breaks and take it offline with me. So I explained that we cannot save everything, and I hope I convinced you. So how do we decide what we keep? What do we monitor? Who decides that? So at one hand, we have the regulator, like the governments, like the IRS, telling us which transactions should be saved and for how long. And on the other side, we have the security officer. She's in charge of keeping our databases safe, and she decides what's hazardous or not. How does she do that? Okay, so first of all, I want you to know that it's a manual job. So it's done manually. And it's done by, when setting up a system, then she's defining user risk groups and assigning users to these groups. And she's defining database risk groups and defining databases to this group and table to this group. And she can also use rules. Well, I'm talking about the database activity monitoring, but it's important for me to know, for you to know that it's not restricted to the database activity monitoring domain or even to big data. Because if your system needs to constantly collect expensive data on a moving target, then you're probably sampling. What does it mean? Let's say you're in sales and you're sending your salesperson to pitch sales for prospects, and you want to know, you're rolling the dice, and you can't send your salesperson to everyone. So you have to decide who are you going to try to sell this, to make this sales to, and you're going to try to do it for the person that is more likely to buy your stuff, right? Or let's say that in Flint, Michigan, or let me tell you a story about Flint, Michigan. US government decided to invest $100 million in digging up and replacing dangerous lead pipes. They had lead pipes that were causing illnesses, and they wanted to replace them. How do you know in which building do you have a lead pipe? They did not have a mapping for that. So the original policy was that buildings that were built during World War II or after, just after, are more likely to be dangerous. You can only know if there is a lead pipe if you send a crew there. And most of the crews that they were sent to these buildings found that the pipes were okay and didn't need to be replaced. So they just wasted money without solving the real problem. So data science for social good offered a new model, okay? And they tried to build a model to help or decide where to sample, where to dig holes in order to improve these ratios of finding lead pipes that need to be changed or replaced. Let's get back to my problem, the database activity domain. And try to understand what are policies, and because we're using policies to define how and which would be sampled. So we said that it's a manual job, so it can't really be done rarely. So it's rarely changed. It's great effort, and no one wants to really do that. And every time a user changes their profile, someone has to manually do that in the system. So as a result, we're only looking into a small part of our users. We only get to know a small part of our users. And our anomaly detection system, which can only learn about the things that she get to know about, knows about mainly about how risky activity looks like, and knows very little about how low-risk profiles behave or how normal users behave. And what if a person like Mr. Lewandowski, the leading engineer, wasn't dangerous until one day he was? If we don't follow him, then we wouldn't have the evidence to prove that he did something wrong, right? $244 million in our pocket. So previous work in the field also are mostly done in the domain of network traffic flows. And they all show that when sampling, we add bias to this anomaly detection. So we want to try to avoid that. I found interesting research in 2015 by Juba and Moscow. They offered a new approach for sampling. Instead of just sampling the small packets that are more likely to be dangerous in denial of service attacks, they said we should first estimate what's the condition of our system. If our system is under denial of service attack, then definitely we should sample these packets. But if we're not under denial of service attack, we should explore and sample the other packets so that we can get to know how does our system work. So what are my research questions? I wanted to know, is the anomaly detection affected by the sampling algorithm? And we've shown that it is. And I wanted to know if there is a change in the user's activity, will it be detected by the anomaly detection based on the policy? Okay, so how does the policy affect the ability of the anomaly detection to detect these events? And, of course, I wanted to know, can we do better than what we're doing today? So come to think of it, sampling behaves a lot like Multi-Armed Bandit. Imagine you're standing in a room in Las Vegas, in the casino, in the slot machine room, and you have a bucket of coins in your hand. And you have to decide which arm to pull to maximize your reward from the coins that you have in your hand, right? So our problem is a lot like that. We have a capacity, and we want to decide which users we would monitor to maximize the risk that we can track and retrieve afterwards. Okay? But mathematically, it's not identical to the multi-armed bandit problem. It is different. Why is that? Well, in the original problem, we are only pulling one arm at a time. In our problem, we have a capacity that may vary, and we want to exploit it as the best that we can. We want to follow and monitor the users that are most likely to be risky. In the original problem, the distribution or the probability to win is discrete. You either win or you lose at each round. But when you're tracking users, when you're monitoring users, you do not lose from monitoring a user. You just may regret not monitoring someone else because you gain something by getting to know someone. And the last but not least, unlike the slot machine where the probability to win and the reward is constant, our users may change their activity during their life cycle. We said that they might change their job, or they might be hacked, or like Mr. Lewandowski, they might decide to change their activity, get pissed at their boss, and just take all the data with them. So what is sampling? Sampling strategy has to return after every round the list of users that we would like to follow the next round. It can do that. The goal of the sampling strategy is, of course, to maximize the reward or minimize the regret, as I explained. We don't want to regret for not following or monitoring someone. And we know that the security officers have a lot of knowledge. We do not want to replace them. Don't be mistaken. We want to support them. We want to exploit their ideas and notions. They have a lot of knowledge, and we want to use it. So we can initialize our system with their knowledge. We're looking for algorithms that will enable us to do that. I'm going to compare three methods. I'm going to compare the rule-based policy, which is the current most common method used by by everyone. And it basically means that when we're setting up a system, then we're defining a list of users that we're going to follow constantly. It sounds like a bad idea when I'm telling you that, but keep in mind that it's working pretty good because the domain expert actually knows what they're doing. They know what is most likely to be dangerous or not. So it's not that trivial to triumph them. Another approach for sampling could be using Gibbs sampling. Of course, again, we could initiate it with the security officer's knowledge to improve the results and to promise faster convergence. What Gibbs sample exploration means that the user's probability to be sampled is proportional to the risk estimate. That means if you're a high-risk profile user, you're more likely to be sampled than a low-risk user. And if we take it to the extreme, of course, we're getting back to the rule-based policy, where you're only sampling the high-risk users, right? And I said that I was inspired as well by the multi-armed bandit problem. So, and strategy inspired by the multi-armed bandit epsilon greedy is C-epsilon greedy. We have a capacity, and we want to both exploit and explore. So we define a proportion of most of the users are going to be picked from the most risky users, and some of the users are going to be sampled randomly. Okay, so we have our three approaches, and now we can compare them. We wanted to know we want to know at any point of the time, if we have a new piece of evidence, how can we tell if it's normal or not, right? So the red dots here represent the current policy approach, where if we're always looking at the same users, then we only know to say about what's normal for these users. Again, I remind you, if the security officer really knows his users and really is really updated with what's going on with the company, it could work well, okay? And we can see that with the epsilon greedy, After only 2 hours, 200 iterations or 200 time frames, we know a little about every one of our users with only 10% of the resources available to us. So if we get a new piece of evidence, we can better estimate if it's normal or not, if it's an anomaly, because we've seen something about it. We can say something about it. So by now, you must be wondering, if you have the data, you're working with IBM, you're working with the database activity monitoring tool, why do you need to sample, to simulate? Why not use the data? So, in real life, the real data that we have is unlabeled. I don't know if a user was hacked, which users was hacked, for how long he was hacked. So, preferably, I would have data that can tell me that has this information. But the most important reason why I should simulate is, as I said before, I cannot collect, when collecting the data that I have, I cannot collect all of it. So the data that I gathered from our customers already been applied, been collected with a policy. So it has the bias that I'm worried about. So instead, to be able to compare between different strategies, I simulate. How do I do that? Well, in 2016, in our work CyberRank, I show that I can assign each transaction with a risk score that represents and reflects the security officer's preferences and priorities for security. Taking these preferences, I can aggregate them into an hourly risk score that reflects the user's activity within this time frame. So each user can be represented with this risk distribution, with all these data points of his hourly data points that are showing his activity. But when randomly sampling these points and going to the domain experts to check whether our simulation looks like the real life or not, they told me that in real life, the user's activity is not random. It has trends, both in the volume of the activity and in the risk of the profile, like the risk of the activity. So it's not always the same. One day you might not be at your desk, and so you won't possess any risk. And another day you might be really logging into really high risk data. But in general, you have a trend. Okay, and we were also wondering in our research questions if we can identify these events. So we want to know what kind of events are we expecting our anomaly detection system to detect. What are these events? What characterizes them? Okay, so we're looking for advanced persistent threats. That means threats that are continuous. It's a continuous event. It's not just someone logging into the computer and just getting data in one query. The basic assumption is that once a user has been compromised, he will continue to behave the same until he was discovered or until he reached his goal, and that may take time. So we want to have so what are the users that we want to produce look like? Some may have high risk profile, some may have like the purple line, some should have a low risk profile like the red line. Some may change during time like the orange, blue, and green lines, but all of them, as you see, have trends. How do we manufacture them? So a user is manufactured by sampling by defining a distribution. We define a distribution by sampling the distribution parameters, and these parameters will go with the user during the entire simulation. And for each time, we will sample an hourly score using these parameters. Okay, so this is how we generate a normal behavior of a user. So it will come from a Gaussian, as you can see. But what is a hacking event? A hacking event is a change in the user distribution, the change in the user Gaussian or his parameters. So we need to resample parameters for this hacking event. But how do we decide if event occurred or not? So at the beginning of and this is one of the strengths of simulating data versus using real data. Because real life data, you don't really have that many events. You can't really count and compare strategies and know when things happen. But if you're simulating, you can implant as many events as you want. So at the beginning of the simulation, we decide on the probability or a chance of event to happen. And at each round, for each user, we flip an uneven coin that will say, was this user hacked or not? Was it, if the user was hacked, then we would then sample the length of the event, because we said it's a continuous event. It's not just a one-time thing. And for this length of event, we would have a new distribution. We would sample new parameters for a new distribution, and all the hourly risk scores will be sampled from this new distribution. To ensure that the anomaly detection learns about the normal activity, we have a burn-in period. So during which we do not introduce new events, and we just teach the anomaly detection what does the normal user look like. But I said, when we came to the domain expert, by randomly sampling hourly risk for the users, it was not enough, it was too random. So to deal with that, we use exponential smoothing to create these wanted trends. As a result, we have the expected behavior. We have some users with high risk profile, they do not change. Some risk with low risk profile, they do not change. And some users may change and vary the way that they behave during time, but everything carries trends. How do we implement the C-Epsilon Greedy strategy? So as I said, we're sampling most of the data, most of our capacity is going for exploiting. That means we're using the most risky approach. And a small portion of our capacity, the reminder, is sampled randomly to generate the exploration motive. So to conclude, if investigating in a good simulation can really help you to learn and evaluate your strategies. But if you want to have a robust simulation, then it must be domain expert driven. We're not looking, remember, we're not looking to replace the experts. We want to help them make better decisions. We want to exploit their knowledge to make better models. So the machine learning must be driven by the domain experts. I also found that going into the multi-armed bandit well-established approaches really helped me to improve the results of my anomaly detection sampling algorithm. And to end my talk, I want to leave you with a pondering. How many of you have watched The Usual Suspects? Well, that's not that many. Do we have time to show the entire movie? It's only 2 hours. Well, you should go after, not now, but after this day, you should, like, maybe later on today, this afternoon, go watch this movie. But in the meantime, I'm going to tell you, it's a story, it's a movie about the police investigating a robbery that went really wrong and ended up in a big explosion. And they are investigating this crime, and they're looking for the man behind the crime, Mr. Kaiser Soza, which no one knows what he looks like or who he is. And they have 5 suspects that were found in sites. And actually, their investigation is led by the assumption that the person that is most likely to be Kaiser Soza, this person that we're looking for, is the one with the most extensive criminal record. But if by following this assumption and they're misled, and they're missing that the whole time they're investigating they're following the wrong suspect. And the one that is less likely to be suspicious, Kevin Spacey, is the one. But I want to say that if they would have used my epsilon greedy method, it wouldn't have happened to them. So don't let yourself be biased. Don't just exploit. Also explore. Thank you very much. I still have time, so if everyone wants to ask questions, then yes.
Hi. I wanted to know, how did you have a prior on the risk? That's the beginning, how you initialize it. So where does that data come from? How?
Oh, okay. So you either your security officer has some knowledge about what's going on in their organization. Many times they don't. Many times they don't until they purchase such a system and start working with it and understanding what they want to follow. But if they have this knowledge, then they can define this, they can assign risk, like say, I think this user, I think you're risky, I think she's not, he's risky, she's not. And we start by this approach and we say, okay, if you're risky, then we're following you, and if you're not, we're not following you. And then after a while, when, as I said, we're not only exploiting, we're exploring. So I would randomly choose people that might have low risk, low probability of being risky, and gain new knowledge about their risk profile. I would monitor their transactions, and I would know during this time frame that I monitored them, what was their risk profile. So I would update after every round the risk profile. So now maybe it will go higher in the list, or it will go down in the list, and we will stop monitoring it. But if I stop monitoring you because I found that you were not interesting at the time, doesn't mean that tomorrow, or I don't know, in a year, you won't be interesting, right? Mm-hmm. So by sampling, resampling randomly, I make sure that from time to time I get to see, to check, oh, is she still not risky? Yes, she is, okay. But and if you're getting risky, then you would get higher in the list. So this prior would affect, and I would start sampling you and stop sampling someone else. Thank you for this question. I feel it really clarifies maybe something. Any more questions? Yes.
You only monitor in the user, from the user perspective, or you monitor the what they do, their activity.
So that is based, well, what I didn't tell you is that I spent this summer, during an internship in IBM, implementing or productizing this into the product. So it is soon, in really exciting, in 2 months, it will be in the product. And it's actually, the algorithm for when it's productized is much more complicated than what I showed you, because working with recollectors adds some interest, but it's actually up to the security officer's preferences. But normally, when you're assigning the risk score using the CyberRank, then you take into consideration both the activity and the data set that you're dealing with, and the time of the day, and all sorts of stuff. So your activity is influenced by many aspects, not just who you are, but also what you did and what did you try to do.
Hi. I have a question. Great talk, by the way.
Oh, thank you.
I wanted to ask regarding the data simulation you're doing. So how do you incorporate all the trends of the day and of the year and different user behaviors into your simulation of the data?
So we have a single measurement that we're basing it on currently. But our single measurement is already taking into the consideration all these trends and stuff that you talk, because the risk score it's affected, or it's assigned by these trends. So if it's not normal for you to do such a thing this time of the year, then your risk score would be higher than normal. And if it's really something that we expect for you to do, then it will be really low, right? So the risk score itself is capturing these trends.
Okay, thank you.
Thank you very much for listening and being a great crowd.